Okay, so next up we have the double act from Telespazio. We've got Richard Conway Garin, which is a software engineer and Garin, but they're going to introduce the European Space Agency EOEPCA. EarthCODE provides a collaborative platform for the science and
Hi there. So I'm Rich Conway from Telespazio. I'm going to start by talking about a project I'm leading, an ESA project called EOEPCA. And handing on to my colleague, Garin, who will talk about EarthCODE, which exploits some of the outputs of that particular project. So first of all, what is an exploitation platform? Technically speaking, it's a cloud platform with data and compute, in particular, obviously, EO and spatial data. And the idea of the exploitation platform is it creates a web-based, cloud-based environment with data compute and tooling to exploit that data, to discover it, and to collaborate and share. And so we have this sort of nominal idea of the value chain, where at the bottom you have the mission data typically, and then you need to discover that data, take it through perhaps some levels of pre-processing to bring it to perhaps analysis-ready data, or maybe pre-processed to act as an input to machine learning. And then as you work through this value chain, you go through data cubes, machine learning, and then ultimately services that allow you to make that data more consumable to decision makers, really. So it's this at the top of that chain, actionable information. And so that, in essence, is the idea of the exploitation platform. That, of course, then creates a problem. As ESA discovered, it dawned on them, I guess, a few years ago now, that you end up with lots of platforms. And users like the services of all of these platforms, they like the data, but they're all in different places. And it's not easy for the users to actually use those services in combination. And that's really the origin of this project, EOEPCA, as we call it. So we've got a two-pronged approach, really. First of all, to come up with an architecture, very much using open standards to try and solve this problem. How do the open standards work? Because you are using well-known standards that have good support from clients, and they are well described, and they are not bespoke, importantly, that allows you to, first of all, interoperate amongst those platforms, and secondly, it allows also federation between those platforms. As well as that architecture, we also we are producing a reference implementation of the architecture. Open source, that's the first point. And the idea is that by creating these, what we call reusable building blocks, we are hopefully reducing the development costs when new platforms arrive. And also we're, of course, aiding the idea of interoperation and federation between those platforms. Quick timeline here. Started back in really 2021 in anger. We've had a few releases. We're now in the second phase. And bottom right, you'll notice that we are now an OSGeo community project. So we're trying to really sort of build up our open source credentials. It's not just sticking the code on GitHub. We want to sort of try and create a bit more of a community around that. So this is a sort of, in one diagram, representation of the architecture. First of all, I always get the question in the past, what's a building block? So I'm going to try and clarify what we mean there. It's really a software component that implements a capability of the platform. And when you break down such a platform, you identify lots of different capabilities. So typically they've got a REST API. We target Kubernetes so that we're not tied to any platform. And so we have a Helm chart, and of course it's open source. We design it so you can either use the building blocks on their own. So if you just want a catalog, for example, we have that. But also we try to provide an added value layer, if you like, where they are integrated into a system. In terms of the community-oriented approach, we're interested in engaging just for requirements to understand, work with people to get their use cases and to drive our requirements, and we'll be very responsive to that, but also to get involved, help design, help develop, and also those who just want to take the outputs and integrate them in their platforms as well. In terms of the community and the standards, OSGO, as I mentioned before, we're now engaging. It's early days for us yet. We're still trying to work out what that actually means for us as a project. But we do have the community status. And of course, OGC, we've worked closely with the OGC over the years, sponsoring test beds and pilots and things of that nature. So there's quite a lot of building blocks. So I'm going to try and go quite quickly. So the first one, the idea, bring the processing to the data. So that's a sort of a core part of an exploitation platform. So we've sort of got two approaches now. We've got the OGC API processing approach, which is built around this concept of the application package. What's an application package? It's a combination typically of containers. So you can containerize your algorithms. It makes it very portable. It makes it very easy for legacy algorithms if you already have them. And we combine that with CWL, the Common Workflow Language, and there's an OGC best practice that describes that as a unit of processing. And that's sort of a portable thing that you can stick on GitHub, host it in Docker Hub, wherever you like, and then you can deploy it to one of these conformant OGC API processes platforms and execute it. The other side is OpenEO. This is new to us. But it's very popular in the community. So now we're working with the OpenEO team as part of our team, which gives you a more sort of client-focused, more closely integrated with the data approach. In comparison to the API processes, which is very general purpose, this is much more analytical and much closer to the data through its bindings for various languages such as Python, R, and JavaScript. And then finally, although we've mostly worked with Kubernetes, we've architected things so that you can plug in different backends, so HPCs and now DAS that we're also working with. In terms of platform resources, we're very much geared towards supporting open science, so it's not just about data. So we've got resource discovery around all sorts of things, obviously data, but workflows, Jupyter notebooks, machine learning models of data, anything really you can think of in that environment. Of course, we do have excellent support for data discovery through Stack, and then access and retrieval through OGC. Also working up that sort of value chain a bit with supporting analysis-ready data with a data cube access building block. This is again something that's quite immature right now. There's a working group in the OGC for the GeoData Cube API, and we're following and we're implementing that as it emerges. We have a component dedicated for harvesting data and pushing it into the platform environments. And then a very important part of it is the workspace, which provides the user using the platform with the ability to create their own storage environments, buckets, manage their data in there, and also augment that with services such as cataloging and data access services around their own data. It could be a user or it could be a project. As we move up the value chain, then we're getting into the sort of analysis and exploitation layer. So we have a dedicated machine learning MLOps building block supporting the training of models, the management of the training data, and the management of the model assets. We have a Jupyter Hub-based environment we call the Application Hub, which of course has notebooks, but it also has an extensible approach for creating what we call applications. So there are web applications that can be used as dashboards to showcase research outcomes, for example. And that's where you're getting into the higher levels of making the outputs of your research much more consumable to lay people. Application best practice is very important for reproducible open science. So we're building in some tooling to help developers follow that best practice, around software development. Event-driven behavior is a lesson we learned from our first phase was to two things really. One, to decouple the building blocks. by using an event-driven approach between them. That helps to solve some problems we had in the first phase where they were slightly too tightly coupled. But also it unlocks automated behavior as well. So we can then hook in through the triggers you get to create automated behavior. For example, systematic processing triggered by some new data arriving in the catalogue. And once a project has reached maturity, they may wish to publish their outcomes. They may have an added value data set and they publish it through a platform, or they may have developed workflows that they want to expose as a service. And if they do so, we have this resource health building block, which will support them to automate monitoring of that to make sure they're offering a good service level to their users. And then finally, some building blocks that are focused around federation. So I've mentioned the two types of processing approach and also the many platforms that exist within that federation. So the federated orchestrator attacks both of those problems. First of all, it supports cross-platform workflow. So it provides a single place where you can submit a workflow and it will distribute the workload appropriately across those platforms according to business rules. And it also supports hybrid workflows that combine the two processing workflow technologies. Linked to that and linked to the federation is an abstraction of data sources. So we have this data access gateway building block, which abstracts the data sources so that you don't need to know the protocol or the IAM policy. It sort of hides the details of that from the user of that library. And then finally, of course, federated identity. So we support the idea of entity across those platforms and make that as easy as possible. So this is my last slide, which I'll use to hand over to Garin. This shows all of our partners and the various building blocks that they're responsible for. So there's quite a lot of companies involved here, all committed to open source. And importantly, within these various teams, they are all operating the building blocks that they are developing. So they all have operational platforms and they're all committed to taking the outputs from this activity into their operational environments to make sure that they are ready for production. So now I'll hand over to Garin.
Thanks, Richard. So I'm Garin from Telespazio, and this is an overview of EarthCODE. So EarthCODE's built using some of the EOEPCA building blocks. And EarthCODE's also a utilization domain, which we provide input and guidance and line code in terms of the building blocks that we need. Yeah, so saying that we provide guidance to EarthCODE to the EOEPCA regarding the building blocks we require. So back some backgrounds. In 2022, ESA decided that more visibility, discoverability, and usability of science results, leveraging interoperability and open science tools and improving communications and community building was necessary. In 2023, ESA also stated that ESA would support fair and reproducible open science practices, complementing this scientific process by software development best practice. And this led to EarthCODE, or the Earth Science Collaborative Open Development Environment, which responds to these recommendations. And in summary, the overall aim of EarthCODE, the EarthCODE portal, is to help users create scientific workflows for experiments and publish them to a repository after they've been verified, so that experiments can seamlessly be reused with specified data and necessary infrastructure according to their open science principles in engaging with relevant communities to further science. And we're committed to open science, so this includes the diagram top right, the use of open data, the use of open source code that utilizes that data, linking both the data and the code together, providing open access to the underlying workflows that do the science, providing capability to support reproducibility, both on the original platform that conducted the science, but also allowing workflows and experiments to be conducted on different platforms, possibly with more data, more compute capability, and the underlying support of open science education, best practice, and community involvement. And to say the project kicked off about 2 weeks ago, so we've just started in anger. In terms of the strategy, EarthCODE is designed to provide Earth system scientists with computational resource, data management tools, and open science support. This is done through the use of a portal, providing a single point of entry, and this gives access to catalogues, which allow resources to be discovered and then managed and supported by the community. There are two roles, key roles, that of the science contributor and the science user. The catalogue will provide access to science data, underlying methods and workflows, and also supporting papers and documentation to describe experiments. EarthCODE will allow science data to be visualized on a map or through a dashboard, provide access to view, execute, and use both workflows and methods on platforms through the use of the ESA mechanism to provide access to funding. Resources include platforms themselves, which there are currently 3, access to fair data management tools, and also learning resources. Through the NOR, it's possible to develop new methods and also to package algorithms into fair and science workflows and publish these workflows and data. And this is done into a catalogue which is provided through the portal itself. ESA will also providing a project results repository, provide long-term access to project results. So even if platforms no longer provide access to experimental results, that can still be they can still be accessed through the long-term project results repository. In addition, EarthCODE provides capability to manage resources and also the support to communicate with the underlying community. We look at the 2 roles. The contributor role will be given access to compute resource on various platforms, ability to develop their science and workflows, to conduct the science on platforms near the data with sufficient compute, and also to publish the results and then interact with the community. The science user will then be able to discover the experiments that have been published. They'll be able to access these experiments, reuse them, either reproducing them to get the same results, or modify them if necessary, and again, interact with the rest of the community. In terms of the management of the project, we have 3 work streams. Workstream 1 is looking at hosting workflows with large compute near the data. Workstream 2 is looking at providing capability to develop these workflows. So the output of Workstream 2 will be executed on Workstream 1. And finally, Workstream 3 is looking at developing a science community based through the catalogue of workflows, documentation, and underlying assets. If you look at this diagram, for Workstream 1, we'll have a number of platforms, and those platforms can submit the products that they produce into GitHub, and they can then be published into the Open Science Catalog to be discovered and used by other users. And for Workstream 2, we publish workflows in a similar way. They're submitted to GitHub, and then once accepted, get published into the Open Science Catalog for discovery and further use. Partners, so currently we are also using the Euro Data Hub or Data Cube, the Copernicus Data Space Ecosystem, and Earth System Data Lab, and we're supported by our partners EOEPCA, Vito, and Brockman Consulting. And also to emphasize the use of EOEPCA Plus. So within the current architecture, within the Open Science Catalog, which has been live for some time now, we use the resource registration building block to ingest assets into the catalog. We use the resource discovery building block from EOEPCA to discover those assets. In addition, we expect to be using the resource health building block in the near future to monitor the operational effectiveness of platforms, including the Open Science Catalog and underlying platforms. And we also use the data access building blocks in Open Science Catalog to access resources, and we expect this to be used in some of the new platforms that we're currently onboarding. One of the concepts that's important in EarthCODE the definitions of workflows, experiments, and products. And that's important because it allows us to understand fully the types of information we ingest into the catalog for current platforms, but it also allows us to form a common understanding of these concepts so that in the future, platforms can start to interoperate. So workflow can be implemented using a number of solutions. One of those could be a process graph, and a process graph will then be defined by the underlying source code. Workflows can also be implemented, for instance, using CWL notation for OGC open processes, again using underlying source code, but alternatively, maybe that a Jupyter notebook is used to define a workflow. Once we have a workflow, we can then start to look at defining an experiment. An experiment will consist of a workflow, the configuration required by that workflow to produce a specific result, and also the input data from the experiment. Once we have an experiment, that will allow the production of products. And if we look at this diagram, an experiment is a mechanism to produce a specific result using, if you like, a workflow which is generic in nature. We also have the concept of defining applications. The applications can be used either to launch an experiment to reproduce it, but also to access the experiment or the product results from the experiments and view it. Additionally, it's possible to have applications that communicate with workflows, which allow users to take an experiment, then modify the parameters to get different results. So we need to describe the workflows, experiments, and applications, but also describe the products and input data. And we do this by using OGC open records to describe applications, workflows, and experiments. And we use stack to describe the input data and the product metadata. In addition, one of the challenges for EarthCODE is how do we take the code and the source code from scientists and allow a workflow to be created to manage that source code. Because scientists are typically more interested in the source code and not so much about the wrappers that provide the workflows. So one of the challenges we have is looking at finding novel ways to convert source code into, for instance, CWL files or process graphs or other workflows, including Jupyter notebooks. In addition, we also are looking at ways to help support the development of workflows using the underlying data that can be discovered within the Open Science Catalog and EarthCODE. Okay, on my last slide, we are open source for both EarthCODE and EOEPCA Plus. Thank you.
Hi, I know you guys are also delivering the UK EO Data Hub project. I'm not quite clear about what the difference is between the EOEPCA and the MDH.
Okay, well, both these projects use EOEPCA Plus building blocks. Both projects use similar approach to defining metadata using stack processes. Now, I suppose it's important to say that EOEPCA provides not only the building blocks, but also the interfaces and the approaches, e.g. stack processes. And so they potentially integrate. So it's possible that the UK Data Hub could be a platform for EOEPCA Plus. So they're very much integrated or strategically integrated, if that helps. Except one's a UK project and the other's the European Space Agency project. Technically, they use a lot of similar building blocks and the same, yeah. I mean, it's worth saying that we're a similar approach is used in other projects. So I've done talks with NASA, with other, Australian Space Agency, other communities doing very, very similar things. And finally, to say EarthCODE is about reusing existing platforms. It's not about creating new platforms. It's about how do we communicate using what we've already got. Thank you.
If you have other questions for Telespazio, Richard and Garin will be actually copied. So we have one more talk before the copy.